I am Mohammad Aftabur Rahman. I am making the body of the robot. I made the body of the robot uh, using a box shape and added a wheel using hinge joints. This is where the shape of the body is, and this is the wheel. I have named it wheel 1. I can now copy and paste and then change the directions of the wheels to fit here, here. I have added the second wheel. I changed the translation and the rotation to fit on the other side. Now I have finished adding all 4 of the wheels, as you can see here. Now I have made the rectangular arena 6 meter squares so that the line can be placed on it that the robot will follow. Now I have changed the color of the arena and the texture, and I have added 3 distance sensors in the front, the left, right and the middle one. They are all pointing downwards. They are going to detect the line and the white space around it. If we go to view, optional rendering and show distance sensor ray, we can see that they are all facing downwards. This one will detect a black line and these two will detect a white space around it.
I'm Hafidul Alam and my ID is 18101080, and now I'm going to build the line which the robot is going to follow, and for this I'm going to use Tinkercad. So I'm choosing Scribble, and now I'm going to draw the line. So here is the line. So I'm making the height as less as possible and choosing the color black. Now I'm exporting. So now I'm going to import the 3D line here. So import 3D model next. So my line has been imported successfully. Now I have to change these values. I have to set rotation values x equal to 1, y equal to 0, and my angle will be 1.5708. The translation value y equal to 0.001. So here is my line. So yes, the line has been built successfully.
Assalamu alaikum, I'm Rahil bin Mushfiq. My ID is 181015552. I'm going to explain the controller code part. Our controller code has been implemented in Python. Here we're going to use the basic time step of the robot. This is the distance sensors, mainly the eye sensors part. We're going to fetch its sensors and append it to this empty list, and also enable each sensors using the time step mentioned here. Also, same procedure goes for the wheels. We're going to fetch the wheels and also set all of their positions to infinity and their velocity to 0. I've also initialized some variables here. Also, after doing multiple experiments, we have found out that our robot works perfectly when our kp is set to 0.05, ki is 0 and kd is 0.15. Also, we have set the base speed to 4. This is our PID function. The proportional part is directly the error which we get from this parameter. The integral part is error plus integral. The differentiation part will be the error minus the last error. And finally, this formula will help us to calculate the balance, which will help the robot to keep in track. Also, we're going to set the last error to error here. And finally, return the balance. This is the set speed function. This function will be used to set certain velocity to each of the wheels according to the conditions. This has two parameters, base speed and balance. The left speed is base speed minus balance, and the right speed is base speed plus balance. We have three conditions here. If the robot needs to move forward, we will use this condition. And if the robot needs to turn left, we will use this condition. And if the robot needs to turn right, we will use this condition. It will be explained in detail in the explanation part of the video. We have used a while loop which will run until the simulation stops. We have kept our threshold value to 675. We are going to get all the sensor values and print them as well. We have 5 conditions here to check whether the robot needs to move forward or slightly right, left, right, etc. Also, set the error value according to our need. And finally, we are going to use the set function using the PID function. Now let's run the simulation. So how does this work? When we start the simulation, we enter into this while loop, then we get all the sensor values, and using the sensor values, we check some conditions. When the mid sensor value is greater than the threshold value, also the left and the right sensor values are less than the threshold value, we set the error to 0 and print the robot needs to move forward. Also, if the robot needs to move slightly right, we set the error to -1. If slightly left, we set the error to 1. If left, then set the error to 2 and set the error to -2 when the robot needs to turn right. Using the error we get, we call the PID function, which will return us the balance, and using this balance and the base speed, we'll call the set speed function. In this function, first we will calculate the left speed and the right speed. Then we're going to check if the left speed or the right speed is equal to the base speed. If that's the case, we're going to set the velocity of right speed to the left part of the wheels and set the velocity of left speed to the right part of the wheels. If the left speed is less than the 0 or the right speed is greater than the base speed, it means the robot needs to turn left. So we'll set the velocity of 0 to the left part of the wheels and set the velocity of right speed to the right part of the wheels. The opposite happens when the right speed is less than 0 or the left speed is greater than the base speed. We'll set the velocity of 0 to the right part of the wheels and set the velocity of left speed to the left part of the wheels. As a result, the robot turns right. You can also see the changes in the console. The robot is moving forward. Now it's moving slightly left. Now it's moving left. And finally, the robot is moving forward.